Okay, so we decided to start by using vertical rectangles. So everything is in terms of x. Your functions are in terms of x. Your the integral is in terms of x. Your limits of integration are in terms of x. There are, however, instances where that necessarily won't work. And when it doesn't work, we need to come up with a different method. And a different method is making one small change, and that is changing to horizontal representative rectangles. For this particular problem, it's not a smart move, because it's going to alter the way that I solve the problem and will require that I need two integrals. The green vertical rectangles, one integral, done, easy peasy. This one, not so easy if you go with vertical. However, if we look at the example that I have in the slideshow, you'll see that one. Okay. So I took two functions. Those are parabolas turned on their sides. And now you see what happens if I decide to use vertical rectangles. I have to create three different integrals. And I get three different representative rectangles. To make matters worse, notice the stuff on the left, I'm going from the function to itself. That's not necessarily very easy to do. How do I do it? Well, I'd have to solve this for y. I would get something like y squared is equal to 1/2 x plus 2, so y would be equal to plus or minus the square root of 1/2 x plus 2. The top is the positive, the bottom is the negative, set up an equation, go from there. It's doable, but tricky. It would be a lot better if I could work with a horizontal rectangle. And that would look like that. It's a little hard to see, I don't know why I made it yellow, but it is. Notice that I can do the entire region now with just one rectangle. Start up in that corner up on the top, slide my way down, gets bigger, 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 till I hit the x-axis, and it gets smaller, smaller, smaller. One integral. A lot of the problems that you're going to see, and in fact, if you 17 on the homework last night asked you to do it two different ways, since we hadn't covered the second way. I understand if you couldn't have been able to do it, but this one in particular, I can do it two different ways. But you'll start to realize that one method is a lot easier than the other. I would argue that horizontal works out better here. What I do need, however, is to say that this is x equals 2y squared minus 4. Now that I'm working with horizontal rectangles, everything is in terms of y. The function should be in terms of y. The height, it's a height of a rectangle, not a width of a rectangle. By the way, how high is that yellow rectangle? dy, correct. Because we're working in terms of y. The other tricky thing is, am I going to take an integral from 2 to negative 2 or from negative 4 to 4? 2 to negative 2. Because that rectangle is sliding up and down. So again, everything's in terms of y. The limits of integration are in terms of y. The functions are in terms of y. You've got a dy on the end of the function. Oops. That's what I wanted. Okay, so top minus bottom no longer works because our rectangles run horizontally. Therefore, we switch from top minus bottom to right minus left. Now, why right minus left?
Because we read from right to left.
No, but that's a good guess. Because what if we were doing this in
German.
Chinese.
China reads right, left to right,
Right to left.
up to down, up.
We read left to right.
We read left to right.
Yeah.
Chinese reads right to left.
Same with German.
No.
No,
Not
no,
German.
no. Left to right.
Okay.
All right, here, this is explained easily.
Christian German is right to
How long is that segment? 5. Now, I understand that you answered because you probably counted squares, yes?
Yes.
How else would you find that segment? The length of that segment? This is at -5, this is at 0. How do you use those numbers to find the length? Is it -5 minus 0 or 0 minus -5?
0 minus negative.
Good, 0 minus -5. It's right minus left, which is the same reason why we use right minus left here. Not because we're in China or Germany. Yeah. Those crazy Germans, you can't trust them as far as you can throw them. Okay. Even though, similar to the first problem you did today, the points of intersection are easy to find on this graph. If they're not easy to find, you're going to have to solve, so I did that. I mean, I got answers that are obvious in the graph, but that's how you would get them. Set the two functions in terms of y and solve for y, because again, everything is in terms of y. And then we set up a nice easy integral. Right minus left. Red function minus blue function. From -2 to 2. Come on. There's the area of the rectangle. Right minus left times dy, which is the height of that rectangle. And then we want to add all those yellow guys up, and when we add them all up, we get that. Can you fn int that if it's in terms of y? Yeah, just change it into x. It doesn't matter what variable it is. X, y, z's, q's. Just put it in as x's on your fn int. It'll give you the same answer. Top minus bottom, right minus left. Yep. Now remember, top minus bottom in terms of x. So you've got a dx on the end. Your limits of integration go from left to right. X values. If you're doing right minus left, you're in terms of y. Your functions are in terms of y. You've got a dy on the end of it, and your limits of integration are the y values from the points of intersection. Some problems, like I said, can be done using both methods. You'll start to realize quickly that one method is going to almost always be easier than the other method. Part of the challenge is going to be figuring out which one to use. I would suggest that you look at your representative rectangle and see which one is going to allow you to do one and only one representative rectangle, and that's the method you go with. If it's vertical, it's x. If it's horizontal, it's y. Questions? Easy peasy, yes?